In this video, we'll try to prove sine of a plus b times sine of a minus b is equal to sine square a minus sine square b, and also is equal to cos square b minus cos square a. And the second one is cos of a plus b times cos of a minus b is equal to cos square a minus sine square b, and also is equal to cos square b minus sine square a. So let's get started. Now let's take on the first problem, which is sine of a plus b multiplied by sine of a minus b. So here we have to apply the formula we already know. So let's do that, which is sine a cos b plus cos a sin b, that is for sine of a plus b, multiplied by sine a cos b minus cos a sin b. So this is for the second part. Now if you notice here, this is a plus b and a minus b. That's the format. So we can write this as a square minus b square, which is sin square a cos square b minus cos square a sin square b. Correct? Now we know that sin square a plus cos square a is equal to 1. Similarly, sin square b plus cos square b is equal to 1. So we can change this to sin square a. So cos can be changed to 1 minus sin square b, that is a trigonometric identity, minus, again cos can be changed to sin, 1 minus sin square a times sin square b. So we would have, let's multiply this, sin square a minus sin square a sin square b, then this would be minus 1. So this will be minus sin square b, minus of minus is plus, plus sin square a sin square b. So we can cancel this out. So we would get sin square a minus sin square b. So that is the first part of the proof we did. Now if we convert sine to cos, which is sin square a to cos square, which is 1 minus cos square a, let's apply the trigonometric identity again, and sin square b is 1 minus cos square b, we would get 1 minus cos square a minus 1 plus cos square b. So we can cancel the 1, so we would get cos square b minus cos square a. So this is how we can prove sine of a plus b and sine of a minus b will have two types of results based on if you want sine or cos. Let's solve the second problem, which is cos of a minus b multiplied by cos of a plus b. So here we have to prove that it is cos square a minus sin square b or cos square b minus sin square a. So here let's apply the formula. So cos of a minus b is cos a cos b plus sin a sin b, and cos of a plus b is cos a cos b minus sin a sin b. So this is again a plus b and a minus b. So we can write it as a square minus b square. So this will be cos square a cos square b minus sin square a sin square b. Now let us change cos square b and sin square a to by applying trigonometric identities. So cos square a times 1 minus sin square b, cos square b is 1 minus sin square b, minus 1 minus cos square a times sin square b. So let's multiply this. We would get cos square a minus cos square A sine square B, then minus sine square B plus cos square A sine square B. So we can cancel these terms. So we were able to prove the first part, cos square A minus sine square B. Now if we apply trigonometric identity again, we can achieve the second part, which is 1 minus sine square A. Let's replace cos square A by the trigonometric identity, minus, we will change sine square B to 1 minus cos square B. So we will have 1 minus sine square A minus 1 plus cos square B. So the 1 gets cancelled. So we would have cos square B minus sine square A. So this is how we can prove cos of A minus B times cos of A plus B has two variations of cos square A minus sine square B, or the one which we proved now. So if you are liking the videos, please subscribe to the channel and also share it with your friends. Thank you so much for watching. I'll see you in the next video.